Today, solving for one variable in terms of another. Strange title, and if I can get through to this lesson what the title even means, I think you'll find that the actual math I'm going to do in this lesson isn't any different than what we've been doing, but it's just a strange thing we have to try to accomplish here. So to try and motivate it, let's just talk about this example here. Sometimes when an equation contains several variables, it's helpful to rewrite it with one variable expressed in terms of the other variables. For example, the following equations all, and it says each, but I said all show the relationship between temperature in degrees Celsius and degrees Fahrenheit. I'm sure you've seen and heard this before, that the Celsius scale and the Fahrenheit scale measure different temperatures outside on a particular day. And here's these are the actual equations that reflect the relationship between Celsius and Fahrenheit. The first one is 5F minus 9C equals 160. And I'm going to jump right in and explain that formula is not particularly helpful. Most people don't use that one at all. The next formula is F equals 9/5 C plus 32. Sort of a complicated equation, but what you have to see is that if you want the Fahrenheit, you just plug in the Celsius right in there, and then you can get the Fahrenheit. And you take the Celsius and you multiply it by 9/5 and add 32. Then the third equation has moved those variables around, and that's actually what we're talking about in this lesson, is moving those variables around. And it's got C equals 5F minus 160 over 9. So this equation's good. You take the Fahrenheit and plug it in there, and then you get Celsius as your answer. So here's the big point of the lesson in these two lines. The rest of it is just using the algebra we've done in previous sections. The big question is, which equation would be most helpful for converting Celsius to Fahrenheit? So say you worked at an American weather station, and you were trying to, on the television, broadcast the temperatures in Fahrenheit, but all you had was the Celsius ones. Which equation are you going to want to use to plug Celsius in to get Fahrenheit? And I hope my explanation has been good enough that you can look right up at those three equations and see that number 2 is by far the easiest equation to use if you wanted to go from Celsius to Fahrenheit, because you just plug Celsius into number 2 and it would give Fahrenheit as the answer. But let's say you were in the reverse situation and you wanted to convert from degrees Fahrenheit to degrees Celsius. That's it. You're at a Canadian weather station and you wanted to broadcast the Celsius temperatures, but all you had was the Fahrenheit ones. Well, number 3 is by far the best equation, because you could just plug the plug the Fahrenheit in for F there, and then you could go 5 times F minus 160 and divide it by 9, and you'd get the Celsius. So, what's the point of all this? The point of all this is sometimes we will want an equation when we have solved for, let's look at number 2, when we've solved for F with terms over here that have C in them, and sometimes maybe we'll want to solve for C with terms over here that have F in them, and that's what this title means, solving for one variable in terms of another. That is, when we solve it, we don't get a number like C equals 10 or C equals 20 when we've solved the equation for it. Right there, we get 5F minus 160 over 9. And that looks weird and it's a big mess, but it actually is a perfect equation if you wanted to use that to then find different Celsius temperatures. Okay? So let's practice on some equations that aren't quite so complicated, and then I actually want to come back to that Celsius and Fahrenheit one and do it as well. I'll find a little space here. So this equation says, solve the following equation for x in terms of y. So it says solve for x. So what I want to do is actually do something that you sometimes do in equation solving, is just sort of establish what you're trying to accomplish here. And what we're trying to accomplish here is get an equation that's not 6x plus 5y, that it's just x equals. So I wrote that down at the bottom of the example to say that's what I'm trying to accomplish here. I'm trying to get down to x equals. And when it says in terms of y, what that means is what's over here when I'm done might have some y's in it. It won't be like x equals 2 or x equals 9. It'll have some y's in it because it'll be a formula, essentially, to find x's. So how do I do that? Well, if I look at my equation, I go 6x plus 5y equals 7. I only want x on the left-hand side of the equal sign, so I don't want this 5y on the left-hand side of the equal sign anymore. So I'm going to use my algebraic tricks to get rid of 5y is I'm going to subtract 5y from both sides. I did that to the left side and also to the right side. On the left side, the 5y minus 5y cancel out, and I get 6x equals 7 minus 5y. And it said solve for x, not for 6x, so I got one more step to go, which is divide both sides by 6, and I get x equals 7. Oops. Let's get my eraser out there for a second. I didn't mean to do it like that. Back to my pen. And I get x equals 7 minus 5y over 6, which I just want to tell you, that's a right answer. That's a really good answer. We're going to find next chapter, so this sort of gets you ready for next chapter. We're going to find next chapter that maybe a better answer is to divide both those terms by 6, and there's no good way to explain why we're going to want to do that, except when we get there, you'll see, you go, oh, isn't it nice that I learned how to do that? You might want to divide each of these by 6, and so I get 7/6 minus 5 over 6y. So I've just divided each of those terms by 6. And again, wait till next chapter. For now, if you just want to do this, that's fine. You just that's a totally good answer for this chapter. But if you sort of want to get ready for next chapter, then just divide it out by the denominator each term there. Okay, let's just look at what we've accomplished, though. It said, solve the following equation for x in terms of y, and that's what I've done. I've solved for x. And let's just switch over to a little highlighter action here. I solve for x on this side, and on the other side, it's 7 minus 5y over 6. So it's like in terms of y. So that strange thing in the title, which was solve for one variable, that's what I did, x, in terms of another. So over here, there's terms with y in there. Let's go back to Celsius and Fahrenheit for just a second here. Let's just look at this equation for a second, and I'm going to try and create equation 2. So equation 1 was 5f minus 9c equals 160. So what I would do is I'd add 9c to both sides, and I get 9c plus 160. And then I divide both sides by 5, and I get 9/5 c plus 32. So that's all that was done to that equation, and I've left a couple of the steps out there just to fit it in there. But basically, I've just rearranged that equation to get that second formula, which is the handy one for doing Celsius. I encourage you, take a minute. It's a little bit more difficult. Take a minute and try and go from 1 to 3 there and see. And if you can do it from 1 to 3 there, you're in great shape for this section. You already have it all down pat. Okay. Next example involving fractions now. So I'm going to bring the fractions back into it, a little fraction practice from a couple of lessons ago. It says solve the following equation for y. Now, they do this in the homework, and in future grades, they won't necessarily say solve for y in terms of x. They just say solve for y, and what they're implying is in terms of x. So don't get freaked out if it doesn't say in terms of x anymore. That's like the first time you see this lesson, we put in terms of x to remind you that when we solve for y, there'll be terms of x, but it's a little bit obvious here that when we solve for y, we're going to have terms of x there. And so I'm going to go right to that last line again, which I love doing, is just going, okay, well, what I'm trying to accomplish is I want y equals when I get to this bottom line here. And these fractions can intimidate you, but we've learned something about fractions. In equations, we can clear them out and not deal with them as much as if we just multiply everything by the common denominator. So I'm going to be multiplying everything by 15. I'm going to do it up on the previous line to save a little space here. I'm going to multiply and everything by that common denominator, which is 15. Well, sometimes I'll use 15 over 1. So it really depends on what term I'm working on there. And this is another way to write it. There's several ways to write it. You can just write the 15 with each one. I like that way. That's pretty handy. Or you can write the 15 in front of a bracket in front of the whole thing like this. And that tells you to do the distribution and everything. So I get, what do I get? 30 over 3x minus, okay, numerator times numerator is 120. Denominator times denominator is 5. When I get to the 6, well, I don't have to worry about the 15 over 1 anymore. I'm just multiplying by 15. So 15 times the 6 is 90, and 15 times the 10 is 150. And so what I get there, oops, I forgot the y, right there. And at first glance, it just looks like I've made the numbers bigger, but if you simplify the fractions, you'll see that 10x minus, let's see, 120 divided by 5, maybe you got to go to your calculator, 24y plus 90 equals 150. So that clears out all the fractions, and now I just want to do that last thing, which is solve for y in terms of x. So I'm going to bring these two terms over. 150 minus 10x minus 90. collect some like terms over there. Minus 10x doesn't have any like terms, so it's just minus 10x. And then 150 minus 90 is 60. And then I'm going to divide both sides by negative 24. I get negative 10x plus 60 over negative 24. And that's a right answer for this chapter. That is totally fine. We did what they asked, which was solve for y in terms of x. Now, for next chapter, we're going to find that it'll be nicer if we divide these individual terms up and simplify them. But you don't have to do this chapter if that's difficult enough already. And I'm going to simplify these fractions here. Geez, what goes into 60 and 24? I think 12 does. So I get 5 over 2 there. Okay, and we're really going to like that answer next chapter for the stuff we're going to do there. Okay, so here's fine. So let me highlight it. This answer here was fine, but I went one step farther there as well. Okay, one word problem, and then we're done. Ralph and Bill work part-time repairing bikes. They are paid $2 to install a tire. So let's let T be tires. And $5 to install gears. So I'm going to go let G be gears. 1 week they earned a total of $100. So they made $2 times the number of tires. They made $5 times the number of gears, and apparently that's got to add up to $100. So $2 times every tire they made, plus $5 times every gear they made, and that apparently last week added up to $100. B, write an equation to express tires in terms of gears. So then what they want is they want an equation that's T equals. So I'm going to go, okay, so 2T equals 100 minus 5g. I've moved that 5g over, and I'm going to divide by the 2. And this is a right answer for this chapter. And what you're going to find next chapter is dividing the 2 into each of those terms gives us an answer we can work with a little bit better. So I'm going to do that here, minus 5/2 g. So tires equals 50 minus 5/2 times gears. And then it says do it the other way. Write an equation to express total number of gears in terms of number of tires. So they want an equation that said G equals. Instead of T equals, we're looking for G equals. Okay, let me start with that original equation again. 2D plus 5G equals 100. And let me just do this one a little bit slower, just in case this is all a little confusing for you. We want G equals, so we want to get rid of that 2T on the left. If we want G equals, we only want G's on the left side of the equation. So we need to get rid of the T's. To get rid of T's, we want to subtract 2T from both sides. And so on the left-hand side, the T's cancel, so I've just got 5G equals 100 minus 2T. And then I'm going to divide both sides by 5, and I get 100 minus 2T over over 5. And that's a right answer for this chapter, for sure it is. There's nothing wrong with that answer at all. But for next chapter, I think we're going to find, in fact, I know we're going to find, that dividing each of those terms by the 5 will give us an answer that'll be more helpful for the things we're going to do next chapter. So I'll just put a double check mark beside that if this is all going well for you and you understand these steps pretty well, maybe go that extra step and save yourself some learning next chapter. Next, use one of your equations to find out how many gears were installed if there were 25 tires installed. Any of the equations will work, but the last one is the best one for sure. G equals, because they want to know how many gears. So I'm going 20 minus 2/5 T, sub in T equals 25. And so I get G equals 20 minus 2/5 of 25. And then G equals, let's see, put the 25 over 1. So I get 20 minus, 50 over 5. G equals 20 minus 10. G equals 10. Therefore, there were 10 gears installed. Okay. Use one of your equations to determine other possible combinations of tires and gears. Well, it doesn't matter what equations which equation I use here. So I'm going to choose a different one instead. I'm going to go up and choose t equals 100 minus 5g over 2. And we're going to find, okay, I'm going to do lots of options. It says other possible combinations. So I'm going to do a few here. Let's say g was equal to 0. If g was equal to 0, let's say they did 0 gears next week, we'd do 100 minus 5 times 0 over 2, and that's 50. So if g equals 0, we get 50 tires. Let's say g was equal to 1. And then tires would be 100 minus 5 times 1 over 2. That would be 95 over 2. That'd be 47.5 gears. Oh, wait. Well, I guess g can't equal 1. They must not have done 1 gear last week, or they would have had to do 95 halves tires. That doesn't make any sense. Probably. You might be able to think of a way to go, well, maybe they are half done a gear or something like that. But, probably it was a whole number of gears. So then you just jump to the next one. You go, okay, well, how about g equals 2? T equals 100 minus 5 times 2 over 2. And I get, on the top, I get 90. Divided by 2, I get 45. And you could just keep going. It's other possible combinations. We sort of suspect that 3 wouldn't work. You can try it out, but you wouldn't get an answer there. So you could go like to g equals 4. And then you get t equals 100 minus 5 times 4 over 2. So that's, let's see, the top's 80. Divided by 2 is 40. You might be seeing a pattern happening here. And let me just give us a jump into next chapter here a little bit. Gears, tires. We found that with 0 gears, there's 50 tires. That's what we got over here. Then we found with 2 gears, there's 45 tires. That was here. And then with 4 gears, there was 40 tires. And you might be able to take a look at that for a minute and see if you can continue the pattern and fill in all the possibilities. There's only going to be about 8 more possibilities here, actually. But that's sort of next chapter. We're going to get into stuff like that. For now, it's just about choosing a couple of combinations, like a couple of numbers. And I chose 0, 1, and 2 because those were easy numbers to sub in. Those numbers gave me matching pairs of gears and tires. Because we actually don't know how many gears and tires they made last week. There's all sorts of combinations that are possible, as you can see here. Maybe they made 0 gears and 50 tires, and that was how they made their $100. $100 was it $100? Yeah. Or maybe they made 2 gears and 45 tires. Maybe that was how they made their money last week. And so there's lots of combinations that are possible. And next chapter will all be about mapping all the possibilities that we get in a certain question. Okay, quick review. Solving for one variable in terms of another just means use our algebraic skills that we've learned of moving things back and forth across equations by adding and subtracting or multiplying, maybe dividing, to rearrange an equation from one form to another, just like we saw right at the start here. All we did in this section was to say, okay, can we take this equation and put it into this form, or put it into this form, whichever form is easier for the particular question we're working on. Okay, we're going to use that skill a lot, so very important homework. Even if you're like, yeah, I sort of get that, I don't need to worry about it too much. We're going to use it so much next chapter. I encourage you to do every single question in the homework so that you're ready for the stuff that comes next chapter. Okay, have a great day.